Hello guys, my name is Vlad Novikov and I work here at Intuit Online Payroll as a senior SRE. I have more than 10 years of experience supporting Linux systems, last 5 of which I dedicated to support all complex solutions and cloud services. Tonight I would like to speak about self-healing systems. During my presentation I will explain the delivery process, explain problems with large-scale environments, the ways to fix this kind of problems. I will also describe how can we improve our solutions by implementing a thing called self-healing systems. And at the end of my presentation, I will explain how we implement this here at Intuit, and basically, in addition to what Dave told, I will share some information what happens here at Intuit behind the scenes. So let's start with a description of deployment process. As many of you know, first thing you need to do to deploy your application is to make sure your code is healthy. So you need to run some integrity checks, unit tests, and after you're sure that your code is healthy, you need to build the application and deploy it to Canary. By Canary here I mean a server or a group of servers that runs an application and which is supposed to run the new version of it and probably connect to a new version of the database with new database schema. Basically, you do it with automated continuous integration and continuous delivery solutions such as Jenkins, Hudson, or something similar. You can also employ things like Bash, Python, Ruby, or any other scripting languages, scripts, in order to help you to deliver the application in a proper way. And you, of course, use SQL to update the database schema. Consider the following case. You need to deliver your application to 100 of servers. So you did all the necessary checks, and your continuous integration system gave you a green light, so the application succeeded all the checks. You managed to deploy it to Canary. Your Canary was green, so basically you ran all the checks and everything worked fine. And then you decided that it's okay to deliver your application to 100 of servers. But for some reason, after you delivered it, 5 servers failed. The reasons can be different, such as failed HTTP checks, some exceptions, some customers are unable to work, or maybe some threads were blocked, and as a result, your application is unable to accept new connections and service your new customers. 5% doesn't sound like a serious number, right? But on the other hand, you never have 100 instances for a lowly loaded service. So if you have 100 servers, you basically have thousands of connections every minute. And 5% means at least 50 customers every minute that are not satisfied with their service. There are many ways to solve this problem, and one of these ways was the scripts, which were called watchdog scripts. And actually this technology appeared in early 2000s when people started using cloud solutions and complex systems instead of mainframes. And as a result, sysadmins supporting these systems had to fix these kind of problems in some way. So they were using Bash scripts or Perl scripts or Python scripts in order to run local checks, then make sure that their application is fine, and if some checks fail, they were starting the application and sending an email notification to sysadmin supporting the system. However, there is one problem with this script. If something happens to one server, everything works fine. If it happens to 5 servers, it also works fine. Basically, you can just disable, so isolate your nodes on the balancer, and your customers will never see this problem. But what if you're under heavy load and one of the checks is a latency check? If you don't have many customers hitting your service, you basically can accept a threshold of response latency within, say, 1 or 2 seconds. But what if you have thousands of customers trying to open your web page or your site or just connect to your API, and as a result, your latency grows up? Watchdog will just starting your servers, and instead of 5 servers, you will start to see more because your customers' sessions will be moved to new servers which are healthy so far, and your initial servers will be disabled. And at next stage, those servers will start being slower. Your watchdog script will do the following thing. It will also isolate those nodes, and you will end up with the next situation. By the end of the day, you will end up with your site being down. So you need to introduce something more complicated which will be aware of your site state. Thus, we need to introduce a thing called a central control unit. Thus, your watchdog scripts or agents will need to gather the information about your systems, disable a node or isolate it on a balancer, perform fixes such as, for example, restart your application server, send an alert, or send a message to central control unit, and then they're supposed to wait for permission to perform following actions, such as bring the application back, or even on the previous step, before starting the service, they need to make sure that they are allowed to do that. In a story I described before, your watchdog scripts will not restart the instances that are responding slowly. So if your application has crashed, watchdog script or agent will restart the application immediately because there's no way to fix the service once restarted. But if there's just a latency growth, it would just send a notification to a central control unit, and central control unit will be able to connect to external monitoring service such as Keynote or New Relic Synthetics, and see that your traffic has grown, and actually it can correlate the threshold of latency with curve of your customer request number per minute. And as a result, this exact metric will not be the reason for application to restart, so you will never be able to see this scenario. By introducing a central control unit, we come to a term of self-healing system. Thus, self-healing system is represented with agents which run on the servers, and central control unit which aggregates information from these agents and decides whether we can restart the application servers or we have to wait till the different actions will be performed. By different actions, I mean if you're running some cloud, you can basically create more instances, and as a result, shift the existing sessions to new instances, thus to unload your existing servers and basically improve the health of your site. On the other hand, if you are running your service in the middle of the night and your actual load is pretty low, what you can do is save money, because you can just cancel the running instances and run, say, 2 or 3 instances, which will be okay for you to service your customers in the middle of the night. Also, if you implement an API for your central control unit, you will be able to manage the agents and, as a result, manage the application servers remotely. As an example, if you have your Jenkins job, which is about to deliver a new version of application to your servers, you can just disable the server, a group of servers on your balancers, bring down the application servers, and deliver the code just by sending an appropriate request to your central control unit, such as please shut down the group A of 10 servers on the balancer, deliver the application, bring them back, make sure that everything all that has succeeded and proceed with other group of servers. The way we are going to implement it here at Intuit Online Payroll is the following. So we are running agents which run sets of checks against application server. Then they aggregate the data based on those tests and send this information through a message bus, which is activity in our case, to a central control unit. On the other hand, central control unit is able to pull your request information from Keynote or New Relic, and if, as I mentioned before, if your curve of HTTP requests goes up, it will say that latency check is supposed to be less important for that site health. On the other hand, as I also said, you can send command directly to central control unit, and it will push a message to a message bus to bring some of those servers down. Let's take a closer look into the implementation of agent we are doing. Each agent contains of two subprocesses, which are prober subprocess and messenger subprocess connected with a message queue. A prober process runs a set of checks against the application server. It employs Bayesian mathematics, so each check has a weight, and if it fails, you just add up this weight to the final check, to the final number. And after we ran all the checks, we just push this number to our central control unit using Messenger. So basically, we just push an appropriate information to the queue. Messenger reads this message from the queue and publishes it through message transport. Right now, we are in the stage where we have just agents running, and as a result, we use email as a message transport. But we are currently working on implementation of central control unit, and as a result, we will use ActiveMQ as a message transport and push notifications through message bus. Actually, this implementation has already helped us a lot, because every winter we have a period called peak season. It means that a lot of our customers are running their taxes, are filing their taxes, and as a result, our services experience heavy load. Before that, our typical day during the peak season was starting at 6:30 a.m. So all the engineers were coming here at the office, monitoring all the servers, like physically monitoring, so watching what's happening on the servers, opening New Relic, monitoring the response time from the servers. This year, we implemented this solution, and as a result, most of the time, we were just there to check the emails from the agents about the application servers being restarted. So this year, our peak season was not this stressful because of this solution. Let's take a look at the code implementation. Probably people will be interested here in the way we are implementing this. So our main process is basically created in the following ways. We create the configuration, set up the logger, and then at this point, we just start the main process called watchdog. The main part of this process is this code called shipboy run. Actually, we call this service a shipboy. The shipboy.run is implemented in the following way. So we create we create a wrapper for sector. Then we create a messenger subprocess, which in our current case is a mail messenger. And after that, we create a watchdog process. And after that, we start both subprocesses and join them. The messenger itself is implemented in the following way. So there is a product class called messenger, which has two methods: listen which listens for the queue. I told you about this before. And if there's some of the messages appears in the queue, we just send this message immediately. Then we inherit from this class with a mail messenger class, and as a result, we just define the way how we're going to send it. In this case, we're building up a mail message and send it through send mail locally. Well, this is about it, about the way we implemented here into Intuit. Here's my contact information if you have questions after this evening, and I'm ready for questions right now.
Hold on 1 second.
How does new debit is used?
So right now we use Neuralix API to monitor the curve of HTTP requests per minute, and right now it's just HTTP requests per minute for our service. In the future, we're going to run checks using well, we're going to run Neuralix synthetics, and we'll be able to correlate the response time for different probes. And for example, if our service starts responding slowly, we'll be aware of this case.
Okay, hold on. What do you use to manage the servers? So this is all like. What do you use to manage your servers? So like this is all like checks and monitors. So if you have to take an action, it's not at the machine level, like give me a new machine, take the machine out of rotation. You're using like Chef or Puppet or.
So we're using Chef right now. Well, we use Puppet, and we're in the process of migration to Chef. And additionally, we will be using AWS API for pre-prod, and in production, we will be using our ESX, VMware ESXi API.
The ActiveMQ and central control unit is also going to be on AWS. Yeah, you said the ActiveMQ message bus and the CC central control unit, is that also on AWS? Is that also going to be on the cloud?
Yeah, for pre-prod it will be in AWS. In production it will be VMware ESX.
Okay, so for this central computing, is that a central point of failure for this entire architecture design? Let's say if that goes down, then, or is there a higher availability design in that itself?
So if it goes down, all the agents will switch to autonomous mode, and as a result, they will work in the way they work right now. So they will run checks, and if application fails, it will be restarted automatically. And by then, we will be aware of the control unit being unresponsive, and we will fix it.
Thank you.
Can you talk a little bit about how you're integrated with the application to get data out of it for alarm, or the component that's actually checking the application?
So basically, right now we're running HTTP checks. So each of our applications has a specific URL which records its health. First thing we do is check for response code, which is supposed to be 200. If it is 200, we measure the response time, and this is another check. We also check the process ID. So if the application is not running, we analyze the directory where this host is configured and check for hotspot. Another thing, actually, yeah, thanks for asking this question because I forgot to mention it. So if the application is in hanging state, we probably want to know what's happening to this application, especially if it's a Java application. So the action we perform is we take a thread dump and analyze all the threads on their state. If the thread is blocking other threads, it is considered to be a root cause, and we send this thread dump to our engineers. In the future, we're also going to implement an interface from central control unit Jira, which we use as a bug tracker, and our central control unit will be analyzing these thread dumps and create an appropriate tickets in Jira, or if there is an existing ticket containing this or similar threat dump, it will be just updating the ticket saying that this occurred once more. Please pay attention to this problem.
You talked about application servers. Is there any way you can extend this technology to, say, databases or other servers?
Yeah, because basically what you need to do is just describe the checks, and they can be not just HTTP checks, they can be any check. So the messenger, the program process is also created in an object-oriented programming way, so you can basically inherit from this class and describe your own checks, such as, for example, measure the database response time, measure the IOPS, and as a result, act appropriately, such as, for example, bring one more read-only replica, redirect your customers to this read-only replica, or bring down. So,
you are using New Relics. I assume you have New Relics agents running on your application.
that's correct.
So what's so special about your agents? Why do you need?
New Relic does not perform a root cause analysis, and New Relic does not restart servers. So it collects all the necessary information, it can trigger alerts, it can connect to chat, and send you notification about that, but it cannot perform the real actions. So some companies who implement a similar solution, they use Salt, and based on some activities or some triggers, they run commands remotely using Salt. In our case, we implement everything using Python agents.
I wonder if your agent can also handle the version rollback or something.
Yeah, right now it's not supported, but it's going to be supported. So it will be able to perform activities you would like to describe. So you can describe a scenario when you just roll back your application version, or when you just start. So, for example, if we create some Jenkins job that will trigger, that will deploy application to Canary, to servers, and some of the failures, some of the checks do not succeed. The agent itself will be aware of that, and it will it will send a message to the central control unit that something is wrong, and the central control unit will be able to roll back everything.
Any other questions?
I can speak. So did you have to choose between active MQ and any other MQ?
It was just the first thing that came to my mind. We probably will implement something similar, maybe a RabbitMQ or maybe GMS. Yeah, there's no specific. Any questions?
Okay. Great.
Great, thank you very much, Matt.